Hi, in this video, we're going to have a modelled context. So we've got some real life scenario. In this case, we've got the height of a ball after a particular horizontal distance x. So initially, as the horizontal distance x is 0, the height of the ball h above the ground is 5. And we're given the maximum point of this quadratic graph. So this is where the y value is at its maximum. And we want to work out what would be the equation of this quadratic graph here. Now remember, we saw that if we have the quadratic equation in completed square form, which looks like this, then whatever the value was after the x, so this plus b, we negate it to get the x value of your turning point. And remember, turning point might be a minimum or a maximum point. And then we use the value after the square, the constant term, as the y value of the turning point. So in this particular case, we've got this turning point here, which is your maximum point. Your turning point is 623. So let's use that. And let's use this kind of backwards. Well, we said whatever this x value is here, we negated it to get the x value, the turning point. So if we negate this value, we will work out what this value after the x is in the equation of the quadratic. So we're going to have a note, by the way, instead of y here, we've got h. So we've got h is equal to, and then we open a bracket, and we're going to negate this 6 to become -6, and that will be the value in our bracket there. Close the bracket, and we've got squared. And then we said that whatever this value is as the y value of our turning point, so this y value here, we just use that as the value after the squared. So we're going to have plus 23 after it. But we've also can see that we've got some unknown value before this square bracket. So this a here before that square bracket. So we don't know that yet. So we're just going to have to put a, and then we're going to have to work that out. So we've got an incomplete equation here. How do we work it out? Well, notice that we've got another point on this graph. Can you see that this point here we know is 0, 5? That's the y-intercept of the graph. In this case, the h-intercept, if you like. So we've got 0, 5. And if we sub that in, we can work out what this a is here. So we know that when x is 0, h is equal to 5. You can see that here. When x is 0, h is equal to 5. So let's substitute that in. We're going to get 5 is equal to a, 0 minus 6 squared plus 23. And then if we just simplify that, 0 minus 6 is minus 6. Squared is 36. We get 36a plus 23. We're going to subtract 23 from both sides. So 5 minus 23 is -18. And then divide both sides by 36. You're going to get a is equal to -18 over 36, which is -half. So we know that a is -half. And then that allows us to put us back into this equation. So we've got h is equal to a, which is -half. And then it was x minus 6 squared, x minus 6 squared. And then at the end, it was plus 23, wasn't it? So that is the final equation of this quadratic model that we have.